I'm going to look at an example of a secant tangent product theorem. This is found in our Common Core 2 packet, section 4, and page 54 talks about this. You see this introduced and problems will follow. So this theorem is easy if the secant product theorem is understood. So the secant theorem stated that if two secants intersect, the product of the lengths of each secant and its external segment are equal. So remember, this is here's a secant. A secant is a line that goes through a circle and not through the center. The section that will go through the center would be the diameter. The section not going through the center is a chord. So an chord is part of a secant. So for this purpose, our secant, we will only be dealing with it from where it touches the circle to where it intersects our other segment of interest. In this case, instead of a secant that would go through the circle, it only touches the circle once. So this is a tangent. That's why it's a secant tangent product theorem instead of a secant theorem. So we have an exterior part and an interior part. So our theorem stated that for the secant, the secant, which we take from where it intersects to where it touches our circle, times the exterior portion of it is equal to the other one. Well, in this case, the other one, it touches the circle and there is no interior portion. So the two pieces added together, well, that would be just this exterior piece times the exterior piece. So it results in just having that exterior piece squared. So this value squared is equal to the sum of these two segments times the external part. So let's put some numbers in just to see an example. In this case, I will choose the interior segment to be our variable, and let's call this external part of our secant 2, and we will give our tangent a length of 4. So we will add up these two segments to find our secant. That gives us x plus 2 times the external part. That is 2. I'll put it in front just for convention. And that is equal to the whole thing added together, which there's 0 plus 4 is 4 times 4. That is 4 squared. And we'll just work through this, distributing as we need to. So we have a 2x, 2 times x, 2 times 2 is a 4, equals 4 squared is 16. Now we'll subtract 4 from both sides. We get 12. 2x is 12, so x is 6. So 6 plus 2 is 8. 8 times 2 is equivalent to 4 squared, and that's true. So that was our secant tangent product theorem.